So let's talk about a problem that, honestly, is a pretty good problem to have. Your application is a huge success, but that success is starting to break your database. Today, we're diving into the solution, Database Sharding. It's the technique that takes a system on the verge of collapse and turns it into one that's ready to scale big time.
Here's the game plan. First, we'll unpack what the scaling problem actually is. Then, we'll get a clear definition of database sharding. After that, we'll jump into the 4 main ways you can actually do it. We'll cover some best practices for getting it right, and finally, we'll see how sharding stacks up against the other options out there.
All right, let's kick things off with Section 1, the scaling problem. Or, as I like to call it, the point where your own success becomes your biggest bottleneck. It's a headache for sure, but it's the kind of headache you want to have.
Okay, so just imagine it. Your app absolutely blows up. Users are flocking to it, creating tons of data and just hammering your servers. And while you're celebrating, all of that traffic, every single request is getting funneled into one single database. That database quickly becomes a massive traffic jam. Queries slow to a crawl, pages hang, and suddenly, the very success you built is threatening to bring the whole system down.
So when you hit that wall, you're at a fork in the road. Path 1 is scaling up, or vertical scaling. This is the simple route. You just buy a bigger, beefier server. More CPU, more RAM, the whole deal. But you can only buy so much server. Eventually, you hit a hard ceiling. Path 2 is scaling out, or horizontal scaling. Instead of one giant server, you bring in a whole team of smaller servers and spread the work across them. It's definitely more complex, but its ability to scale is practically infinite.
And that idea of scaling out, well, that leads us directly to the star of today's show. Let's talk about the ultimate divide and conquer strategy, database sharding.
So what exactly is database sharding? Well, at its core, it's a way of taking one gigantic, slow database and breaking it into a bunch of smaller, faster, and way more manageable pieces. We call those pieces shards. The best analogy is a library that's gotten way too popular. Instead of trying to cram everyone into one massive building, it opens up smaller branches all over town. Each branch has just a part of the book collection, making everything faster and less crowded for everyone.
Okay, so let's get the ground rules straight. Sharding is a type of horizontal scaling, where we split data into those logical chunks called shards. Now, each shard lives on its own separate database server. And here's the really important part. Every single piece of data, every row, exists in exactly one shard, no duplicates. And even though the data is spread out, all of those shards use the exact same database structure, the same schema, as the original.
All right, now that we know what it is, let's get to the really interesting part, how you actually do it. Welcome to the Engineer's Playbook. We're going to walk through the 4 primary strategies for sharding a database. First up, we've got key-based sharding, which you'll also hear called hash-based sharding. The idea here is pretty clever. You pick a piece of data that should be well distributed, like a user ID, that's your shard key. Then you feed that key into a consistent math formula called a hash function. The result of that formula tells you exactly which shard that user's data belongs on. This slide gives us a super simple example. Let's say you have 3 servers. You can just take an application ID and use the modulo operator. You divide the ID by 3, and the remainder, which will always be 0, 1, or 2, tells you precisely which server to go to. It's a simple, predictable, and consistent way to distribute the data.
Now, the beauty of this is, in theory, it spreads the data out perfectly evenly. But, and this is a big but, it's only as good as the key you choose. If you pick a bad key, or if a few keys suddenly get a massive amount of traffic, you create what's known as a hotspot. That means one server gets totally slammed with requests, while the others are just chillin'. So everything hinges on picking a great sharding key.
Method number 2 is range-based sharding, and this one's probably the easiest to wrap your head around. Instead of a math formula, you just divide your data based on a range of values. Like the slide says, you could literally say all customers with names from A to P go on shard 1, and everyone from Q to Z goes on shard 2. Super straightforward.
On the plus side, this is really easy to implement and understand, and it can make certain queries very fast. The big drawback, though, is that it can lead to very lopsided shards. I mean, think about it. Are there as many last names that start with Q through Z as there are from A through P? Absolutely not. So shard 1 is going to end up bigger and busier, while shard 2 doesn't have nearly as much to do. Okay, now for something completely different. The first 2 methods we talked about split the data by rows. User A goes here, user B goes there. Vertical sharding flips that completely. Here, we're splitting the data by columns. You're not separating users from each other, you're separating different features about those users.
This example nails it perfectly. For a social media app, you could put all the user profile info, like usernames and bios, on one shard. Then, all the data about who follows whom goes on a totally different shard. And finally, the massive, fast-moving stream of all the actual tweets lives on a third shard. Each major feature gets its own dedicated database.
This is great for query performance because a request for a user's bio only has to hit one specific server. But you can see the potential problem, right? You can still get hotspots. That shard handling all the tweets is going to be working way, way harder than the one holding user profiles. Plus, making changes to your database schema gets a lot more complicated when it's spread out like this.
And our final method is directory-based sharding. This one is interesting. It adds a middleman, a sort of traffic cop, into the system. You have a central lookup table whose only job is to act like a map or an address book. It keeps track of which piece of data lives on which shard.
So the flow looks like this. Your app needs some data, but it has no idea where it is. First, it has to ask the central lookup service, hey, where's the data for user 123? The service checks its map and replies, that's on shard C. Then your app can make a second connection directly to shard C to do its work. It's a two-step process for every query.
The huge win here is flexibility. You can move data between shards anytime you want, just by updating the map, and your application code doesn't have to change at all. But there are two really big downsides. First, that extra lookup step adds a little bit of delay or latency to every single request. And second, this is the scary one. That central directory is a single point of failure. If it goes down, your entire system is blind. No one can find anything.
Okay, so we've got our 4 strategies. But just knowing the playbook isn't enough, right? You have to know how to execute the plays. So let's talk about getting sharding right, because it is all about finding and maintaining that perfect balance.
Really, this comes down to a few key principles. It all starts with choosing a good sharding key, one with high cardinality, meaning lots of unique values, so data spreads out naturally. For instance, using country as a key would be a total disaster. You'd create these massive hotspots. You also need to use techniques like consistent hashing, which is a clever algorithm that minimizes how much data has to move when you add or remove servers. And remember, sharding is not a set-it-and-forget-it solution. You have to constantly monitor how your data is distributed and be prepared to rebalance the shards as you grow. Honestly, automating this is the only way to stay sane.
All right, let's pull back for our last section and look at the big picture. Because as powerful as sharding is, it's not a silver bullet. It's one very specific tool in a much larger toolbox. And being a good engineer means knowing the right tool for the job.
This table sums it up beautifully. See sharding up top? It's the champion for handling massive loads of both reads and writes. The cost you pay is that it's architecturally very complex. Now look at the other options. If your app is mostly read-heavy, maybe replication, just making copies of your database, is all you need. If you have a few viral items everyone's trying to access, caching could solve that problem without a major overhaul. And partitioning? Think of that as sharding light, all within a single server. It helps organize huge tables, but it doesn't distribute the load. Each strategy solves a different problem.
So, when you boil it all down, sharding is the strategy that lets an application grow from a success into a global phenomenon. It is absolutely complex, but it's the key to scaling to handle millions, or even billions of users. We've gone over the what and the how, but the real engineering challenge, the real art, is knowing when. So I'll leave you with this to chew on. For that next big idea you have, what would you choose as your sharding key?